Hello and welcome to this repair tutorial, and today we're going to look at a Marantz PM5005. Specifications: RMS power output, frequency range of 20 Hz to 20 kHz, standard human hearing range, and that's 45 watts per channel into 8 ohms, or that can increase up to 50 watts with 2x4 ohm speakers. When you look from the front fascia, you have it selected between system 1 and system 2, or via the headphone jacket if you deselect the speakers just for personal listening. And you can also select these speaker sets from the remote control as well if you wish. It also supports direct mode, so just for clarification then, if you select direct mode, that just will bypass what we term as the tone control circuit. So this is your bass and treble controls. And then you also have a loudness switch as well on the front fascia. And then in terms of inputs, it supports a moving magnet cartridge for phono, i.e. vinyl turntable connection, and that's 2.2 millivolts and it's 47 kilohertz, which is standard. And then for your CD input tuner, network, record 1 and record 2, input range would be up to 200 millivolts and with an impedance of 20 kilo ohms, and then weight 6.7 kilograms, and then dimensions standard for this amp, so 105 is height, 440 then width, and with a depth of 370. So the report for this amplifier, and I'll sort of go into a little bit more detail as we go through, was that the amplifier would seem to play okay maybe for 3 or 4 hours, and then the customer may experience that it would look as if it went into mute mode, or it would go into protection mode, and you would hear the relay inside for the power transformer just disengage, and then it would just sort of restart again. Or if the mute just flashed up temporary, and then they heard distortion, and there's quite a lot of distortion then, as if maybe there was an issue with the input signal, but it wasn't that. So when you look in detail with regard to this type of fault, there's a number of issues with this, and what I'm alluding to is this talk or this aspect where you have an intermittent fault. And for anyone who is doing any form of repair, and you will all have experienced this maybe for a motor vehicle that you own, or maybe a piece of equipment that you own, an intermittent fault, if you're trying to track it down, is probably not the easiest thing. And the reason being is that it can come in many ways. So you may well have a report of a fault, and then you get in the workshop, the particular piece of equipment, and you try to recreate, what would be the fault conditions to see this issue. And often you may be able to recreate it, but often you can't. So under all test situations, it doesn't put in an appearance, and then you advise the customer, or you send the device back to the customer, and then sure enough, as soon as they plug it in, the fault puts in an appearance, and then it's back in the workshop again. Commonly these sorts of faults, if you can create them or get them to trigger, you may also have very, very limited time to do any form of fault analysis. So it maybe only puts in an appearance for 2 or 3 seconds. That's not long enough for you to get any test equipment in there or to try and monitor anything. And with amplifiers where you have a power startup relay, it's even more difficult, because once it goes into protection mode, it shuts off the main power to the amp, so making fault finding even more difficult. For service people, we do have tools available, so if you are able to create the fault, it may well be due to, for example, a thermal issue maybe with an electronic component, and it's not uncommon that when components heat up, the fault starts to manifest itself. We use what we call component freezer spray to cool down the component to try and correct the issue, and then as the component heats up, then the fault reappears. But we can accelerate that. Early days of service, you'd have like an hairdryer, and then you could just use that hairdryer just to heat up the component. But I'll use the terminology today as a heat source. You use some form of heat source just to increase the temperature, and then use the freezer spray then to sort of cool it down. So that was really the complaint with the customer, or not with the customer, but the issue that the customer was advising. So when the amplifier first went on test, yep, it worked perfectly, and you couldn't get any sort of fault condition or anything to occur. And I think it's more so by chance than anything else that I switched off the amplifier, just to sort of do a board inspection, and then when I powered it back up, I got the headphones connected, and straight away I could see the issue. Not that the amplifier went into protection mode, but definitely the audio coming through on both channels was distorted. quite distorted. So I was looking then for a common cause. Now, I have experience of these amplifiers, as I do with many other types, and when you look in the video, what I'm showing here is an extract from the service manual. So you are seeing the DC power circuits. Now, what I also show later on in the video, you can see where I've put the test probe onto one of the regulators, and I'll go in more detail now. And what I'm doing is I'm measuring the output then from one of the voltage regulators, and it's very low. So how I sort of came to conclude that this particular component was the issue, when we refer to what you see here in the video for the schematic, you can see that there are multiple voltages. So the one which I'm concerned about, and I sort of highlight it here, is the 2 plus and minus 15 volt regulators. So there's U8101 and U8102, and the one which was failing was the negative 15 volt rail. Now you can see that it goes to the tone circuits and the preamp. So of course if you lose that 15 volt feed, then no wonder you got this distorted sound coming through. Now the manufacturer of this is KEC, which is Korean Electronic Corporation. So this is a very, very big brand, you know, dating back to sort of 1969, and they sell millions of electronic components to original equipment manufacturers which are used in a broad range of equipment. Now this particular regulator, although this is the issue, and on the channel you'll also find other Marantz amplifiers 5 or 6000 series which again had a failure of one of these types of regulators, but I've also seen this many times with the Pioneer A10 and 820 because they use exactly the same IC. So when I was looking at this fault and it manifested itself, if you just put your hand just above U101, there was really no heat to sort of sense as such, but when you went above the U8102, you could definitely feel that there was more heat being generated, and hence, you know, when you metered it, you could see that the voltage output, you know, was very, very low. Now you could conclude that, hey, that could be something further down within the circuit, you know, which was pulling it down. Could have been, but or was there a loss of incoming supply? So you make the measurement on the incoming, and it was about negative 26 volts DC, so all was good. But you also saw that the output from the regulator was also fluctuating as well. So as with any series regulator, as we term these components, even with a varying load up to whatever it's specified, so there could be 1 amp regulators, even if the load changes, it should maintain that precise voltage output, and that was not the case. So rather than just simply replace the negative 15 volt regulator, because exactly the same regulators are used throughout the amplifier, and you see here that it will also be used to generate the plus 5 volt supply, and it says the motor volume driver, and then also you can see that we have a plus 12 volt supply which is for the speaker relays, and then loudness and source direct as well then. So rather than, as I say, just replace the faulty regulator, I know they're all made by the same company, and I just did a block change then and installed replacement ST Micro brand into the amplifier. Now what I am not saying is that KEC produced defective parts. That's not what I'm saying. But what can happen, as with any piece of equipment, there could be, for example, a batch run where components are manufactured, and from a particular date code you may have an issue. And you see this with other amplifier repairs which are on the channel, like the Behringer iNuke. There is a Schottky diode which is very, very common, and that fails. But on later models, then you didn't see the issue. So I see this really around the same kind of date code. So that's why I suspect that this is more of a batch problem than maybe if you went and sourced a component today, you know, which was brand new. So straightforward repair, as I've shown in the video. I show the different regulators, but I also show that the board has been removed, and that's quite straightforward. And then you can then just desolder and then install. For the 12 volt regulator, you can see that it has an additional heatsink that it's mounted onto. So it's just a case of just putting some heatsink compound on the back and then screwing it to the heatsink, and all is good. And then reinstalling the board and then testing. Now, when I did the initial measurements before the negative 15 volt regulator was diagnosed as the reason for issue, it was a little bit low. If I compared it to the 15, you know, the 15 was about 14.94, all within spec, but the 14 volt was kind of drifting a little bit, and probably about 14.2 volts. So it would have got changed anyway if it hadn't have sort of put the complete failure fault in place. So I didn't just replace the regulators, because that's affecting the preamp circuits, etc. I just double checked the bias for this amplifier. Now it wasn't excessively high, but you did see that it wasn't set then to the 20 millivolts, which is the factory level that it should be. So I show this in the video, as I have with previous videos. It's straightforward. You don't connect any input to the amplifier, you just set your volume control to minimum, all of your other controls then at midpoint, and it's a case of just putting your meter across the test point, as we're showing here for the output stage, and then adjusting the bias preset till you read 20 millivolts. Within, if you around about 20 millivolts, that is fine. But normally leave the amplifier probably running for about 20 minutes or thereabouts, and then you can then do a final adjustment if you need to. So really that brings us sort of to a close on this repair. Not very complicated, quite straightforward, but whatever you've learnt on here, remember that if you're regularly repairing amplifiers, this is not going to be a one-off. I've got no doubt that you may see other failures of this particular KIA7915 negative voltage regulator, or the positive one, and you can use that to diagnose, for example, the A10, A20 amps, as I mentioned, or the Marantz 6000 and 5000. So I really appreciate you stopping by, and as always, if you have any questions or you need any advice or information, by all means email audioamplifierservicing@aol.com, and I'll be more than happy to help and assist any way possible. Alright, until the next time, thanks very much, cheers, bye bye.